Okay, hello everyone. Welcome back to the differential chapter. We will continue what we have after having the first formula. So this is the 15.2. We will discuss about the chain rule, which is used to derive the composite function. So in this chapter, you will learn to find derivative of composite function. And also please recall what you have about composite function in 9th grade. Before having the second formula, let's review the first formula of y equal ax to the power of n. For this first formula, this is actually a single term in a polynomial function that you can arrange it in addition or subtraction. Then where a and n are constants, then you can have dy dx. The derivation of y with respect to x is a is the constant, multiply with n is the power, times x to the power of n minus 1. So you can see that the power is decreased 1. So with this formula, let's see, we have two special cases. The first one is when n equals 1. You can have y become a times x, and dy dx will be only a constant a. For example, if you have 6x, then dy dx is 6. When n equals 0, then y will be only a constant a. Then dy dx will be 0. Yeah, for example, the derivation of 7 is 0. So this is the second formula. It is about how to differentiate y equal x squared plus 1 to the power of 5. So you will think maybe to expand the expression, since if you learn in binomial, you can expand the expression and you will have 6 terms in addition and you can differentiate it one by one. But of course, it is time consuming. So it is not a good idea to expand the expression. Instead, we will do this. We separate this function become two functions, because actually this is a composed function. Then here you will have u, which is x squared plus 1. All function in the bracket become u. Why we name it u? Yeah, it is just a common function name in differentiation. So after have x squared plus 1 as u, then y will be u to the power of 5, right? Then what we do next, we can differentiate it independently. U, which is x squared plus 1, we have du dx. The function is u and the variable is x, so we differentiate u with respect to x. It is named du dx. And for y, which is u to the power of 5, here the function is y. And be careful, what you have is a variable u. So when you differentiate, what you have will be dy du. After that, this is named the chain rule. When you chain these two independent derivation, become dy dx. Yeah, since what we need is dy dx, it is coming from the product of dy du with du dx. Let's continue to solve the problem. Then we have now x squared plus 1 and u to the power of 5. The result of the derivation of the single function is du dx, which is 2x, and the dy du, which is 5u to the power of 4. After that, the next step is chain them together, become dy du times du dx, which is 5u to the power of 4 multiply with 2x. Last one, you can just substitute u back to x squared plus 1 and have 5x squared plus 1 to the power of 4 multiply with 2x, and it can be simplified, become 10x times x squared plus 1 to the power of 4. The conclusion for the formula, if you have a composed function, usually you will see that the function is have any bracket and have a function of variable of x, or we name it as u. So for a times u to the power of n, it is a composite function that the dy du become a times n times u to the power of n minus 1, and then this is the dy du. Then you will still need the du dx, or usually we abbreviate it as u prime. Then you can having a chain rule for the dy du and the du dx, and you have a times n times u to the power of n minus 1 times u prime, so that you will have this dy dx. Okay, this is your homework, the second part of this chapter. Please do page 340, number 1a, 2a, 3a, 4a, 5a, and 6 and 8. Okay, related with the chain rule, we will discuss it again in our class. And please note, if you have any question, then please let me know. Stay safe, everyone. God bless you all. Bye-bye.